Hey, so we're looking at this problem, and it says solve the compound inequality and write the solution set in interval notation if it exists. So I'm going to start by rewriting them, and I'm going to write x plus 8 is greater than or equal to 9, or 10x plus 5 is greater than or equal to -8. All right, I'm going to start by drawing my little line here. And whatever I do to the left-hand side of the line, I have to do to the right-hand side of the line. So I'm going to subtract 8 from both sides here so that this plus 8 and minus 8 cancel. And I'm going to get x is greater than or equal to 1. All right. And the order of my inequality stays the same because I didn't multiply or divide by a negative number. If I did multiply or divide by a negative number, I would have to flip my inequality sign. Alrighty. Now looking over here at this other inequality, I have plus 5, so I'm going to subtract 5 from both sides. And I'm going to get 10x is greater than or equal to -13. Yeah. Alrighty. I'm going to draw my little line again. And whatever I do to the left-hand side, I have to do to the right-hand side. So I'm going to divide by 10 on both sides so that these cancel. And I'm going to get x is greater than or equal to -13 over 10. And the order of my inequality stays the same because I divided by a positive number, not a negative number. If I had divided by like -10, I would have flipped my inequality and it would have been x is less than or equal to -13 over 10. All right, I'm going to box these inequalities real quick. And I'm going to look at my number line and see where they're happening. So on my little number line here, I'm going to do 1 and I'm going to do -13 over 10. All right. So looking at this first inequality, it says x is greater than or equal to 1. So greater than or equal to means I'm going to have a filled in circle because I'm including 1 here. And I'm looking at all the values that are greater than 1 or equal to 1. Alrighty. For the -13 over 10, I have x is greater than or equal to -13 over 10. So greater than or equal to means I'm going to color in my little circle here, and I'm looking at all the values that are greater than -13 over 10. All right, so I like to test points to see where my solution set is. So if I picked a point down here, like if I picked -5, which is less than -13 over 10, it's not going to satisfy this one, and it's not going to satisfy this one because it's not greater than -13 over 10, and it's not greater than 1. So this doesn't work. If I picked 0, zero's in between here, in between these two values. 0 is greater than -13 over 10, and it's less than 1. But because I have this or here, that means it's included in my solution set if it satisfies one of these or both of them. Alrighty. So it's like if you're talking to a little kid and you say, you can have pizza or candy, the little kid's going to say, well, I can have both because you said or. You said pizza or candy. That means I could have pizza and candy also. So it's the same kind of situation here. We could have one inequality or another inequality or both. So this 0 works. So that would be in our solution set. That's good. And if I picked a number greater than 1, like 5, 5 satisfies both of these inequalities. So they work. That's like getting your pizza and your candy. The 0 is like getting your pizza or your candy. All right. So all that to say, your solution set would include values in between -13 over 10 and 1 and numbers that are greater than 1. So our interval notation is going to look like -13 over 10 we did a bracket because we include negative 13 over 10. And we're going to go all the way to infinity. And we don't include infinity because we can't ever get to infinity. And this would be my final answer.